this, can this function have domain all real numbers? No, because exactly. So x squared minus 1 cannot be 0, right? Yes, we agree? Okay, so which makes, when you factor, let's say that's one way, you can take the square root after you move 1. So x cannot be plus or minus 1, right? So the domain cannot be this. Just a comment. I didn't look at everything you wrote, but I just saw that, right? So remember, the ratio of two functions exists only if the denominator is not 0, right? Just to refresh your memory, okay? Okay, so I'm assuming that you didn't get the chance to look at a lot of problems. Okay, so that's why I wanted to remind you. So a ratio does not exist if the denominator is 0. That's why we have to state this restriction on any ratio. Now, if I have a function that is x plus 1 over 2, I'm not going to write that 2 is not 0. There would be no point. But if I have x plus 1 divided by x minus 1, I have to write that x is not 1, because otherwise the denominator will be 0. So it's required, right? We are convinced? We're not convinced? Right? So we know that the division by 0 is undefined. Okay. So let me just refresh your memory on what we did last time. We looked at 5 different ways of determining new functions. So if we are given f of x as a function and g of x as another function, we can add them, we can subtract them, we can multiply them, we can divide them, and we can also create the function composition. Well, here are many other options, right? I can do also g comp f and so on and so forth. So these are 5 different ways. Sum difference product ratio, one thing that require common domain, and this one does not require the common domain. But what could be the problem here? That the range of one function does not work well with the domain of the next one. But I'm not going to request that here. We do this extensively in the next course to find the domain of the function composition. Here we only find the domain of these functions. This is the common domain always, and this may or may not be the common domain, depending on the denominator. Okay. Then we looked at inverse functions. The notation is this. It does not mean 1 over f. We know that 2 raised to negative 1 means 1 over 2. No, this is just a notation. And the notation is f inverse. And we said that if two functions are inverses of each other, then f comma g and g comma f must equal exactly. If f and g are inverses of each other, because they cancel their effect on x. Plus 7, minus 7. Two operations that cancel their effect on x. Multiplication by 3, division by 3. They cancel their effect on x. If I give you 9, and I ask you multiply it by 3, you'll say 27. And then I'll say, now immediately divide by 3. And then I'll say 9 again. So nothing happened to 9. Multiplying it by 3 and then immediately dividing it by 3, nothing happened to it. So if two functions are inverses of each other, the function composition, this one, the fifth way, not any of this, but the fifth way has to give us just plain x. We also showed last time that the graph of a function, if it is 1-to-1, will have symmetric, the graph of f inverse, with respect to what line? Or which line? Which line is this? Y equals x. So two functions, if they are inverses of each other, the function composition has to give x. And also, their graphs will be symmetric with respect to y equals x. Why? Because f, let's say, has 1, 2. What is the ordered pair for f inverse? 2, 1. So that's why it's a reflection with respect to this line. And all points on this line have the same x and the same y. So this is what we studied last time. Maybe, and also how to find the inverse function of a one-to-one function. So maybe we should review this a little bit. So let's choose a function, actually two functions. And let's review 12.1 first. Let's say with problem 4 on page 717, we are given f of x, which is x squared minus 2, and we are given g of x, which is 3x. And I'm going to change the question. I'm going to ask you all 5. So in other words, I'm going to ask you the sum, the difference, the product, and the ratio, and function composition, both of them. Okay, a quick review before we move on. Okay, first we have to find the domain of f. Can anyone give us the domain of f? We should not be thinking that much. These are polynomial functions, and we should remember right away that the domain of a polynomial function is always everything. So the domain of f and g, everything. So what will be the common domain then? Everything. And the domain of 3 functions will also be the common domain. And I don't have to mention it again in my proof or my solution. Which functions have the same domain with the common domain always? The sum, the difference, and the product. I don't have to mention this again. But what I don't have yet is the domain of the ratio. So now I'm ready to find them. And always it's always recommended to write the definition so you don't make a mistake. F of x plus g of x, and then you copy x squared minus 2 plus 3x. And then in this case, I have to arrange it in descending order. So this is it. Now for the difference. I write the definition, f of x minus g of x. And I get x squared minus 2 minus 3x. And I have to write it in descending order. And that will be the difference. I don't have to mention the domain of this and the domain of this because I already wrote it up here. And fg, which is f of x times g of x, and f is x squared minus 2, parentheses, and times 3x. And I have to distribute 3x to those two terms. So I get, when I distribute, what do I get?
3x cubed.
Excellent.
6x.
Very good. And again, I don't have to mention the domain. It's clear. But now when I determine the ratio, I have to write f of x over g of x. I have to copy x squared minus 2. I have to copy 3x, but I cannot leave it alone. Because I know that if I ask you, evaluate this function for, you will tell me I can't. Which value of x? For which value of x you will say, I can't evaluate it. For 0. So x cannot be 0. What will be the domain of the ratio then? From the common domain, I must exclude the values that create a problem. In this case, there is only one. So how will I write the domain of the ratio? Excellent. So now I'm done with these four, but I have not completed the fifth, which is function composition. Okay, so now f comp g. What is the definition of f comp g? I have to write it. This is the fifth way of creating new functions from given functions. F of. Yeah, the times will be this one. Okay. So f of g of x. I have to replace g of x now. At this point in time, I'm replacing g of x. By what? Good. And now I'm looking at f. What does f want us to do to what it's called the argument? The argument is 3x right now. What does f request us to do to the argument? Square the argument and then minus 2. Very good. So I'm squaring the argument and minus 2. But when I square a product, what do I get? This is a product. When I square 3x, it's like 3x times 3x. What do I get? 9x squared minus 2. And this is done. Now I also want the other one. And I would like to start by writing the definition. What is the definition for this one, for the second one? G of f of x. Excellent. I have to copy f. So I will write g of, what does f represent? X squared minus 2. And now I look at g. I have to do what g is asking me to do to the argument. Now the argument is no longer x. The argument is x squared minus 2. What am I going to do to it? Very good. Just multiply by 3.
I think that's where I struggled, was knowing the way you just put it, referring to the x as the argument.
Yes.
It helped me tremendously.
Yeah, what I'd like to do, and I think it helps, is when I look at f, this is what f says. When I look at g, this is what g is asking me to do. Or you can say this is the argument. So I'm asked to square the argument and subtract 2. Very good. Okay, now what if I ask you, for example, find the g comp f at negative 3. What will you do?
You replace the argument.
Right. So there are two options. One option is I have the function. I worked hard for it. I have the function. So I'm going to replace. So I have 3 negative 3 squared minus 6. Right? I have to square first by the order of operations. I get 9 times 3, 27 minus 6, 21. But here's another option. Assuming I don't have the function and I don't feel like determining the function, here's another way. What will you do to determine negative f, g comp f of negative 3 if you did not have the function? So first I'll write the definition. G of exactly. So first, indeed, I have to determine this. So here's my x. I'm sorry, here's my f. I have to plug in it what? So negative 3 squared. 9 minus 2. So this is 7. So what I'm really asked to determine is g of 7. I better get the same answer. Otherwise, math makes no sense. So now I have g. I'm asked to find g of 7. How much is g of 7? 21. So I have two possibilities. If I have the function, I prefer using the function. If you don't have the function and say, it takes too long to find the function, then this is the second route. It will take you to the same answer. So basically, this is all we discussed in 12.1. And one other thing I would like to ask you is to decompose this function for me in two functions. So let's say f of x is the cube root of x plus 3. I would like you to find an inner function that you will evaluate first. Let's call it g of x, inner. And I would like you to find a function f of x that is the outer that you will evaluate last. After you get the number from g of x, then you will plug it in the next function, which is the outer function. So what will be the inner function? There is more than one correct answer here. What will you consider the inner function? That's perfect. Once you are done and you find one number, this will be one number, what will be the next function that you will apply to that number? Very good. It's guaranteed that this sequence, f, g. Oh, I'm sorry. Let me change this into a different name because I used f and g. I'm going to say this is h. Sorry about that. Okay? So the outer will be outer. The inner will be inner, meaning the inner function has to be the closest to x. Because first I apply g, as you told me, the inner function is applied first. And then when you are done with that, then you apply the outer function, which is the second function. G is the closest, G is applied first, and then F is applied to G as requested. Good, so that was section 12.1. Now let's look at 12.2. We talked about one-to-one functions. Can anyone remind us what a one-to-one function is? That is a function. To each x only one y. But the special property is to each y only one x. Yes. So a one-to-one function will look like this in bubbles. And in graph will look not like this. This is not one-to-one. Why? By the horizontal line test, this function for a particular y has 3 different x's. More than one, anyway. So here's a function that is one-to-one. We all know this function. What is this function called? We graphed it many times. How do we call this function? This one. Linear. This is one-to-one. For any y value, there is only one x value. Therefore, it's one-to-one. Therefore, it has an inverse function. Okay, so I would like to find the inverse function using that 4-step procedure. Let's say for f of x equals 3x minus 9. Is this function one-to-one? What type of function is it? We know many functions from this course. We know radical functions. We know linear. We learned quadratic in the previous chapter. And we also know absolute value. Okay, which of these 4 is this function? Of course, this is a linear function. What did we just decide? It is one-to-one. It will look like this or like this, I don't care. Positive slope or negative slope. But either way, It will be 1 to 1. Okay, perfect. Step 1 in finding the inverse function. What was the first step? Good. I am allowed to do that. They mean the same thing. Step 2.
Interchange or swap x with y.
Done. Where I saw x, I put y. Where I see y, I put x. Good. Step 3.
Solve for y.
Good. What should I do to solve for y? I need to solve this equation for y. Good. X plus 9 equals 3y. And finally, what do I do to both sides to get?
Divide by 3.
Good. You can write it as x plus 9 over 3, or you can divide each term by 3, so that's another option. X over 3 plus 9 over 3, which is 3. It doesn't matter, whichever you prefer. I personally prefer this, but it doesn't matter. So in step 4, what will I write in step 4?
Replace y with the inverse.
With the notation F inverse. That's it. Any questions? Now, if I ask you to graph these two functions, I would like us to graph these two functions on the same coordinate system. Let's graph them. So I'll start with the function. So f of x equals 3x minus 9. When x is 0, how much is y? Very good. And the ordered pair that I need to plot?
0, negative.
Excellent. When y is 0, think in terms of moving negative 9 to the other side and dividing by 3.
X equals 3.
Very good. X equals 3, and the ordered pair is 3, 0. Good. I'm ready to graph this function. Give me the ordered pairs that I would use to graph it.
So 0 and negative 9.
That's it.
And then 3 and 2.
That's it. Thank you. Good. I draw the line and extend it. I write y or f of x, it doesn't matter, equals 3x minus 9. Can anyone, without doing any work, give me two ordered pairs so I can graph the inverse function with no effort?
Negative 9, 0, and 0, 3.
Is it clear what happens? This point goes across y equals x, and this point goes across y equals x. So this line is y equals x, and this point, these 2 points have to be, we say, equidistant. They have to be at the same distance from it, from this line. The same thing here, same distance. And now I'm ready to graph the inverse function. It has this point where the function crosses y equals x. I don't know what that point is. I'm just going to pick something and say 5, 5. Please reverse 5, 5. So it has to be the point for the other function as well. This I was able to reverse from 3, 0 to 0, 3. This I was able to reverse from 0, negative 9 to negative 9, 0. But this one I can't, because if it's 5, 5, it's still 5, 5. So it has to be a common point. Now, if the two graphs do not cross this line, then they don't have to have a common point. And we discussed that last time. Okay, so now we can, with all this knowledge, we can move on to 12.3. Don't get scared about 12.3. It's a totally new function that we have never seen before. Okay? It's a totally new function. And yes, if you would say, as if we didn't have enough functions, the answer is this is a very special function. And it appears in real life situations more frequently than the ones that we learned so far. It has very wide applicability. So 12.3, the exponential function. Let me ask you a question. When we looked at the absolute value function, why do you think that function is called the absolute value? Because it has what in it? Why do you think it's called the absolute value? Because it has an absolute value in it. Why do we call the square root function the square root function? Because. So what do you think we call, why do we think, do you think we call this function, I haven't even presented it, but why do you think we call it the exponential function? It has to have an exponent, and this time the variable is the exponent. Okay? So the function looks like this. Examples, like 2 to the x, or 1/3 to the x, or 10 to the x, or, very important, e to the x. Notice that the function has the variable that is the exponent. The base is just a number. In the first case, the number is 2. In the second case, is 1/3. In the next one is 10. And in the last one is e. All these are 4 different numbers. But the variable is the exponent. That's why we call it the exponential function. Okay. Now, there is a problem here. And here's the problem. I'm asking you this. Can I raise 1 to the 4th power? Yes, I can, and I get 1. Can I raise 0 to the 3rd power? And I get? Good. And can I raise -3 to the 2nd power? And I get? Good. Well, it happens that these numbers as base, or bases, 1, 0, or negative, are not allowed in an exponential function. And the question is, wait a minute. I can raise 1 to any power I want, 0 and a negative number, I can raise it to any power I want. How come that 1, 0, and -3 or any negative number is not allowed in the exponential function? The reason is not obvious. Here's why. Note, the base of an exponential function, we will call it lowercase b, must be greater than 1 or between 0 and 1. So either strictly greater than 1 or between 0 and 1 only, and here's the reason, only because its inverse function cannot be defined or cannot exist when the base is 0, when the base is 1, or when the base is a negative number. That's the only reason. The base can be 0, 1, and negative. But if we allow it, we will not be able to determine the inverse function. The inverse function will not exist. And this function is 1-to-1. And this function, we'll see after we graph it, this function will have an inverse function. So that's the only reason why the base of the exponential function must be either a number greater than 1, like 1.1, 1.3, 5, 6, 10, e, or a number between 0 and 1, like 1/3, or 1/2, or 1/5. or 1 over 16. Any number, positive number between 0 and 1, or any number greater than 1. Okay, so let's look at both situations because the shapes, the graphs will not be identical. So if the base is greater than 1, like for example 2 to the x, and then we'll look at another example with a base less than 1. Let's create a chart of values. Let's think about domain of this function. The domain does not refer to the base. The base is a number. It's a given number. The domain refers to x. So now it's a different question. The question is, can I raise 2 to positive numbers? Can I raise 2 to negative numbers? Like 2 to negative 5? Yes. Or 2 to negative 2? Yes. Can I raise 2 to 0? What do I get when I raise 2 to 0? 1. So what will be the domain of this function? Anything, right. So negative infinity to infinity. Perfect. Let's pick some values like negative 2, negative 1, 0, 1, and 2. I did not pick them scientifically. I just picked them around 0. Okay. So now I have to plug in negative 2 and get a number. 2 raised to negative 2. 2 raised to negative 2, by definition, this is 1 over squared. And this is 1 over, that's it. Now please plug in negative 1 and give me the y value. How much is 2 raised to negative 1? Very good. One more time, plug in 0 and tell me what you get. Perfect. Please plug in 1 and tell me what you get. Please plug in 2 and tell me what you get. Okay. Now, this is not a scientific way of looking at infinities. Okay, but for this function, this is what we need to do. So I'm going towards infinity. 1/4, 1 over 2, 1, 2, 4, 8, 16, 32, 64, 128. Where am I going? Absolutely. Now let's go this way. 1 over 2, 1 over 4, 1 over 8, 1 over 16, 1 over 32, 1 over 64, 1 over 128. I have this piece of paper. No, that's somebody's test. I can't do that. I have this piece of paper, and I take a little piece, and I give you, and I give you, and I give everybody on the planet. And when I get to somebody in India, what will be left from my piece of paper? Nothing. Nothing. Absolutely nothing. Good. So now let's graph this function. Good. So please give me the first ordered pair that you want me to plot. -2, comma. A little bit difficult, right? I'm going to say that this is it. -2, comma 1/4. What is the second order pair that you want me to plot? Here it is. This is easier. The next order pair you want me to plot? Good. The next one?
1 and 2.
And the last one so far? 2 and 4. Please look at this graph. We haven't finished yet. This is the fastest possible growth that is characteristic to the exponential function. Can I have a higher growth than with base 2? Yes. Base 10 will be even closer to the y-axis. Base 15 will be even closer. But in general, the exponential function is the fastest growth, has the fastest growth possible. Here's the graph. Look, it's approaching 0, not 0 exactly, right? So this is the graph. Does not touch the x-axis. So this is f of x equals 2 to the x. Can anyone tell us whether this function is 1 to 1? By the horizontal line test, if I cut it, how many, for each y, how many x's will I find? So it's 1 to 1. What is so special about 1 to 1 functions? Why do we even talk about them? Because they have, and only they have, inverse functions. Okay, can I graph the inverse function? I don't even know what it is, but I can graph it. Can you give me points so I can graph the inverse function, please? 1/4 -2. This point gets transferred here. Excellent. Next point that I should plot to graph the inverse function. Next point. Next point. This is the inverse function of 2 to the x. Now, we like to write the domain and range mathematically in this way, as you know. F, not the inverse, just f, is defined on what is the domain of 2 to the x. Excellent. Now I need you to identify the range. Please look at the graph of f and identify the range. Right. We don't know anything about the inverse function, but we do know its domain and range. Can anyone identify the domain and range for the inverse function? Exactly. That's what the inverse function does, right? It's defined on the y values of the function and returns everything where they came from. Excellent. Although we don't know anything about this function, look at this. We know its graph. We even have points to graph it because we knew how to graph the function. And we know its domain and range. What more do we want? Right? I'll tell you the name and everything in a minute. Okay? I would like to graph the other function with the base less than 1. Can you say that this function, if I say it's increasing all the time, would you agree? Base more than 1. Can I also say, obviously, that its inverse is increasing all the time? So when the base of an exponential function is greater than 1, the function will always be increasing. Its inverse as well. Ready for the other shape? Okay. So let's look at f of x equals 1/2 to the x. It's still an exponential function because the variable is the exponent. However, the shape will be different. It's a base that is less than 1. Okay. And yes, I will also show you how to graph them with a graphing calculator. Okay, what is the domain of this function? Same thing. Everything. It's a nice function, friendly. -2, -1, 0, 1, and 2. I did not pick them scientifically. I just said, okay, let's see what happens, not too far away from 0. Now I have to plug in -2, then -1, then 0, 1, and 2, and then write the values of y. So 1/2 raised to -2. Here's one way. I will replace inside 1/2 by 2 to -1. Would you agree? Is 2 to -1 the same thing with 1/2? And now I copy the base. What do I do with the exponents? Perfect. So then 2 squared is? Please plug in -1 in the function and give me the value. Very good. Please plug in 0 and give me the value. Stop me if something is not clear. Yes. Yes. 1. Exactly. Thank you. Please plug in 1. Please plug in 2. So now let's see what happens far away. We looked at what happens in close to 0, but now I need to determine what happens far away. So I'm going this way. 1, 2, 4, 8, 16, 32, 64, 128. Where am I going? Good. Let's go this way. 1/2. So I have one piece of paper, and I divide it by 2, but then I divide it by 4, and then I divide it by 8, and then by 16, and when I get to you, how much will you get from this? Let's graph. The graph is interesting, but what I'm interested in is word problems, and you'll see they're extremely interesting, in my opinion. Very simple, very simple. Very simple problems, but I just want you to see the applicability of this. Very simple, trust me. This time I can say that. Okay, please give me the first ordered pair.
-2, 4.
Next.
-1, 2.
Next.
0, 1.
Next.
1.5.
Next.
2.5.
It's very clear, right? Here it is. And this is the graph of 1/2 to the x. We notice right away that this function, in comparison to this one, with the base greater than 1, is a function that is always decreasing. So when the base is less than 1, the function will always be decreasing. Is it 1 to 1? It will have an inverse function. What do you think the inverse function will do? So when the base is greater than 1, both are increasing. When the base is less than 1,
Both decreasing.
absolutely. So please give me points.
4 and -2. 2 and 1. 1 and 0. 1/2 and 1. 1/4 and 2.
It's f inverse for the function 1/2 to the x. Perfect. And now I would like for this function to find the domain. What is the domain of the 1/2 to the x?
Negative infinity to infinity.
What is its range?
0 to infinity.
And now we know the inverse function's domain and range. We don't know its name, but we know its graph, and we know domain and range. What is it?
0 to infinity. This is the domain. Range is negative.
Right. So if this is AB, this is AB. This is BA. Okay, perfect. Okay, on page 736, before we look at word problems having to do with this function, I would like to look at problems 21 through 36. Solving exponential equations. I'll choose the first one and then you feel free to choose the next. I will start with 30, which is 2 to the x equals 64. They are very complicated equations, not the ones we are going to look at in this course, however. In this course, both sides, we will be able to present both sides with the same base. The left-hand side, there is nothing I can do to it. It's 2 to the x. But there is a way of rewriting 64 as 2 to some power. What is the power? Good. So this is 6. Now here is what I'm telling you. I'm telling you the following. These two numbers are the same. They are equal. And they have the same base. We cannot simplify bases or reduce bases or anything like that. So this is the concept. These two numbers are the same. And their base is the same. What has to happen to the exponents for them to be equal to each other? They must be the same. Because if this is 7, 2 to the 7th will never equal 2 to the 6th, right? So the exponents have to be the same. So this is it. X must be 6 for 2 to the x to be 64. There is no other way. Please choose any equation you want. They are not the difficult type. The difficult type, they come much later. Not in this course. So please choose anything you want. Okay, 36. You'll choose the next one. 4 raised to 3x minus 7 equals 32 raised to 2x. And you can say, what is this? This looks hard. Not at all. Both sides can be presented with the same base. What base? Exactly. So please tell me how to write 4 with base 2. 2 squared. Everything now, which is 4, is raised to 3x minus 7. Please find a way of writing the right-hand side, which is 32, the base on the right-hand side, with the same number. With the same base. 2 to the 5th. So 2 to the 5th, and everything raised to that power. Now on the left-hand side, copy the base, and please tell me what to write. Depending on the operation we need to perform here. What is the operation? 6x minus 14. We multiply the powers. The same thing on the right-hand side. 2 raised to the Very good. Again, the same concept now. This equation needed some prep. But now we are down to the final step. And here's how we think. I have two numbers that are equal to each other, and they have the same base. If they didn't have the same base, the story would have been totally different. But they are the same and they have the same base. What has to happen to the exponents for these two numbers to be the same? Yes. So from here, 6x minus 14 must equal 10x. And please note, I am not reducing or simplifying the base. I cannot do that. And I know how to solve this equation. What should I do? Okay, you can subtract 6x, so you have negative 14 equals 4x. And finally, x equals negative 14 over 4, simplified to negative 7/2. And this is it. Yes, the equations require you to remember the exponential rules. But once you get it to this level, then from here, all you have to do is just set the exponents equal to each other. Please choose another, and then we should.
You have to go back and plug that negative 7/2 2.
To check. You want to check. Excellent, excellent, excellent. Let's do that. So a few things here that I wanted to do anyway. So first, let's go to y equals and clear if you have anything else. I was working on something else. That's why I had. Okay. So now I would like to graph 2 power x. And I will use the standard viewing window. Here's the graph. The calculator is lying. The graph does not touch the x-axis. So there is a little gap all the time. Eventually it may touch it. But the calculator is lying here. Okay, so if I change the viewing window, let's say, at least the y values between -2 and 2, you will see it will look differently. See here, it shows that from, I was already changing it. From -2, it was the same graph with the x-axis, which is incorrect. Now all of a sudden, it shows that it's the same from -4. If I change that further, it will show again that there's a gap. So please remember, what we graphed is correct, what you see here is not. So that was one thing. Then if you want to graph the other function with the other situation, which is 0.5, 1/2 raised to x, and I want to graph it with the standard viewing window, I'll get the same mistake. That's not possible. As you know, the function does not become 0. It becomes 0 at infinity, so far away that we cannot even talk about it. So the fact that it shows, the calculator shows that it starts overlapping with the x-axis is an error. And we know that that's not the case.
Well,
I'm sorry?
I mean, that's just to do with the graphical limitations of the calculator, but if you go into the table, it shows that it really isn't.
Yes, but so where do you think it will become the same with the x-axis?
I mean, it's not going to.
It's never going to.
Right, it's not going to.
Right, right. But how it shows here, for someone who has never seen this function before, someone who was not present today in class, may think that the graph overlaps with the x-axis starting from +2 even, which we know it's not the case. Okay. The other thing I wanted to show you is how to plug it in. So let's go back to, yes, I need to do that. Now, in order to show that this -7/2 is a solution, it is better if I put the left-hand side minus the right-hand side. And when I plug in -7/2, what should I get? Okay, let me say this again. Maybe it wasn't clear. In order to check, I want to create one function. So I'm going to move this to the other side. So 4 to 3x minus 7 minus 32 to 2x. And in this function, I will plug this in. What should I get when I plug it in? What should the answer be? So when I move this quantity to the other side, what is left on the right?
0.
Of course. Only this number will get us 0. If you plug in here any other number, it's not going to give us 0. Right? So when I move this to the other side, I just created a new equation, but it's the same with the original one. So because I don't want to plug in two different functions. You can plug into different functions. You can plug in this, and you show that they are equal in number. Or you move this quantity to the other side and you plug it in and you get 0, right? Same thing. It's up to you. So if you want to create just one function, I will put 4 caret in parentheses 3x minus 7, close the parenthesis, outside minus 32 caret in parentheses 2x, close the parenthesis. And now I go to second and table. What do I plug in? Good. Or negative 3.5. Is that okay? And when I press enter, what should I get? Which guarantees the negative 7/2 is the solution. Any other number will not. This is a one-to-one function. I cannot, like in a quadratic function, I cannot find two values that make y the same. Quadratic function looks like this. For y equals 1, I will read 2x values. In this case, for the exponential function, there is only one answer. It's a one-to-one function. So if I plug in 1, do you think I'm going to get 0? Of course not. If I plug in 5, do you think I'm going to get 0? No. There's only one answer, which is negative 3.5. Very good. Please choose another exponential equation so we can look at word problems. 34 it is. 34 on 736. And we have 125 raised to x minus 2 equals 25. And as I mentioned in this course, both sides, you will be able to present both sides with the same base. What base are you thinking of? 5. So the right-hand side will be 5 raised to the... Yes, we like to stick with prime numbers as a general rule, although sometimes non-prime numbers may work. The left-hand side, I need to replace 125 with the same base. Very good. 5 cubed indeed. So the right-hand side does not change, but the left-hand side becomes what? So 5 raised to? Excellent. Now I'm back to the same concept. These two are the same number, and they have the same base. What has to happen to the powers? What should I write? That's it. Which means 3x equals 8, which means x equals? That's it. If you have any doubts, you don't have to create one function as I presented it. That's fine. You can create two functions. So let's do that for this function, for this equation. The left function is 125 caret in parentheses x minus 2. The second function is, if you don't want to do what I'm doing, what I like to do is just one function, but it doesn't matter. I go to second and table. What do I plug in? Very good. In both functions. And then we'll do it. We'll do it. A divided by 3. And I press enter. I have to get the same number on the left and the same number on the right. So y1 and y2 have to give me the same number when I plug in 8/3. Do they? This is it. Good. So can I look at word problems now? As you can see, they're very simple. Very simple. You cannot find anything easier in this book than these problems, I think. So let's look. Problem 41. The equation, and you choose the next. The equation y equals 140,242 times 1.083 raised to x models the number of American college students who studied abroad each year from 2000 to 2009. From 2000 to 2009. In the equation, y is the number of American students studying abroad, and x represents the number of years after 2000, which means x equals 0 represents 2000. Round answers to the nearest whole. Part A. First of all, let me ask you this. What type of function is this? Is it a linear function? Is it a quadratic function? Is it a radical function? Is it an absolute value function? What type of function is this? It has the variable at the exponent level. Exponential. Right? Perfect. So now the first question. Estimate the number of American students studying abroad in 2004. I am told x represents the number of years since 2000. So what am I asked to do? And how much is x in part A? 4. And what do I have to do?
Take the 1.083 to the 4th power, multiply it by 1.4.
Exactly. Just plug it in. Perfect. In y equals, please do not do anything in steps. Put in the entire function from the beginning. 140, 242, parentheses, 1.083, raised once again to which power? 4, and press enter. That's all. This is it. Oh, this here is what I did. Okay, I'm sorry. I have to punch in. Oh, okay. Sorry about that. I have to put x, not 4, in there. Okay, and then go to second and table. Okay, and punch in 4, enter. And the answer is, and I'd like to go over it and see what it is. So the answer is, and they want us to round to the nearest whole. So 192927. So f of 4, 192927 students. Now in part B. Assuming this equation continues to be valid in the future, use the equation to predict the number of American students studying abroad in 2015. What does that mean? How much is x?
15.
All I have to do is just plug in 15. 1, 5. 1, 5. And here's what I got. 463772. So f of 15, 463772 students. Can we find something easier? This is it. But we cannot do this by hand. This cannot be done by hand. I will never be able to raise 1.083 to the 4th power by hand. Not possible. Okay, choose any problem. (46) on page 737. The atmospheric pressure P in pascals on a weather balloon decreases with increasing height. This pressure measured in millimeters of mercury is related to the number of kilometers h above sea level by the function P of h. 760 multiplied by 2.7 raised to negative 0.145 h. We're on to the nearest tenth of a pascal. Find the atmospheric pressure at the height of 1 kilometer. So h is in kilometers, P is the pressure. Find the atmospheric pressure at a height of 1 kilometer. What do I have to do? I have to find so P is the pressure, h is the height in kilometers. I'm asked to find P of 1. So we'll find it in a minute because we want to create another function in the graphing calculus. Find the atmospheric pressure at the height of 10 kilometers. What am I asked to determine now? That's it. So now let's create the function. So in y equals, clear, 760, and multiplied by 2.7. You have to put the caret and then in parentheses, negative 0.145. We don't have h in the calculator, so that's why we use x. It doesn't matter. And now we go to second and table. What do I plug in? 1. And then what do I plug in? So let's hover over the first one. So it says to the nearest tenth. So 658.1 Pascal. And the other one, 180 Pascal. Any questions? What I wanted to stress here is how useful this function is. We did not have this variety of applications ever so far. We had the height and throwing a ball and throwing the ball from a distance, throwing a ball from a building, but these are so different. Okay, should we do one more or we move on? Move on? We got the idea? Okay. We do not cover 12.4. According to my department, that's what they wanted. They said no. Okay. We do have to cover 12.5. Logarithmic functions. Logarithmic functions. When we graphed 2 to the x, can you remind me how to graph 2 to the x? No points, just remind me how to graph it. Something like this, right? And I was saying at that time when we graphed it that this is the fastest possible growth. We also said it's 1-to-1. We also said it has an inverse function. And we graphed the inverse function like this. Right? A few minutes ago. This is what this function is all about. This is the inverse function. It has to have the same base. It's a fancy notation. Do not get scared by it. I'll write down how we read it. It's L-O-G, log, base 2. It's low. It's in a suffix, right? It's not next to it. Log base 2 of x. Log base 2 of x. And I'll explain how the mechanism works and how the function works in a minute. Now, when we graph the other one, the other shape, we graphed this. If you remember, 1/2 to the x. And we said this is a one-to-one function. It has an inverse function. And then we graphed the inverse. This was the inverse. Same point for both. So this is the inverse function. How will I write the inverse function? Knowing this, how will I write this one? What do you think? Give it a shot. What is the difference? The only difference is the base. So log base 1/2 of x. This is what the logarithmic function is all about. But let me show you the mechanism, because we didn't do much. This is what we knew from before. This is no news, just the notation is new. We have not seen this before. This is the notation for log. Okay. Here's the mechanism. Before we start, I'm going to write a note. Note, the most important concept in this, I would really say chapter, but I'm going to just say section, is this. Any logarithmic equation can be written or replaced by or with an exponential equation. This is in plain English. This is in words. I'll show you mathematically how we write this in a minute. The most important concept in this section is this. Any log equation can be written or replaced by or with an exponential equation, and I'll put a comma, and vice versa. Any exponential equation can be replaced by a log equation. I'm coming back to the bubbles, I didn't forget. But I need this concept for the bubbles. So if I write a logarithmic equation, here's how I'm going to write it. Log base b of x is a number y. This is a log equation. This is a log equation. I am going to replace it. This symbol is what we call double equivalency. What do I mean by that? The right-hand side implies the left-hand side implies the right. So in other words, from here I get here, from here I get here. Double equivalency. So here is the procedure. I start with the base and go counterclockwise. Start with the base, counterclockwise. B raised to y is x. B raised to y equals x. This is the exponential equation. So I changed a log equation into an exponential equation. And I can go backwards as well. Okay, so now, coming back to the bubbles, bless you, I want you to give me an exponential function and 3 numbers, a positive, a negative, and 0. Any exponential function you can think of. So f of x equals, let's say 3 to the x. That's an exponential function, 3 to the x. And let's say negative 1 and 2. So I picked 3 numbers, a negative number, 0, and a positive number. Please give me the value through this function for each x value. So if x is negative 1, and I plug it in 3, and I get 3 to negative 1, what should I write? 1/3, perfect. When I plug in 0, what should I get? 1. When I plug in 2, what should I get? 9. I didn't do anything. I only used a function that is exponential, and we picked 3 numbers. We got their correspondent. Now, I want to show that the inverse function is, one more time, what should the inverse function be? What do you think? I have to use this fancy notation, right? Log base 3 of x. I have not convinced you yet that when I apply log to 1/3, what should I get back if this is indeed the inverse function? When I apply log base 3 to 1/3, what should I get as the answer? Of course. When I apply log base 3 of 1, what should I get as the answer? Otherwise, it will not be the inverse function. And when I apply this to 9, what should I get? I have not convinced you yet. I will in a second, using this. So I apply log base 3 to 1/3. Here's what I'm doing right here, this side. Log base 3 of 1/3 is an unknown number. I don't know what it is. But this is equivalent to, and please tell me how to write the exponential equation now. 3 to the y equals 1/3. And now we know exponential equations from a few minutes ago. I can present both sides with the same base. So the left-hand side is 3 to the y. What do I replace the right-hand side so I have the same base so I can find y? 3 to negative 1. These two numbers are equal and they have the same base. What should y equal to? And no other. Negative 1. So I'm coming back to my bubbles. I think I convinced you that through this function, 1/3 returns for sure to negative 1. Okay, I will apply the same mechanism and the same super important concept for log base 3 of 1. So log base 3 of 1 is an unknown number y. Now I can change this using the double equivalency. I can change it using an exponential equation. How do I write the exponential equation?
3y equals 1.
Yes, 3 raised to y equals 1. You didn't say that, but I just want to make sure. It's 3 raised to a power, not multiplied. I'm good. Now I'm asking myself, how do I present 1 with a power of with a base of 3? No problem. 3 to which power will be 1? 0. Now these two numbers are equal and they have the same base. How much should y be and no other? 0. So I think I convinced you that when we apply log to 1, what do we get back? So this must be the inverse function. Let's do the last one also.
Can I
Yes,
ask you-
yes.
So it's just
No.
here, but 3 to the 0 power, how are you getting 1?
Very good. Excellent. Let's talk about that. Would you agree that 4 divided by 4 is 1?
Yes.
Well, this can be rewritten as 4 raised to 1 minus 1. Right? So 4 to the third divided by 4 to the second power is 4 to 3 minus 2, which is 4, correct? I copy the base and subtract the exponents. 3 minus 2 and I get 1. Power 1, correct? So the same thing I do here. I copy the base and subtract the exponents. 1 minus 1. So this is 4 raised to 0. But it must equal 1 because 4 over 4 is 1. Except 0. So any number raised to 0 is 1 except 0 raised to 0, which is not 1. You have to wait till calculus. 1. This is an indeterminate case. It can be anything. So 0 raised to 0 can end up be e, or 5, or 10. So it's an indeterminate case, and we discussed that in calculus 1, and it depends on the limit that we look at. Yep. So, but did I convince you? First of all, 4 over 4 is 1.
Yes.
And then I copy the base and I subtract the exponents and I get 4 raised to 0. So 4 raised to 0 must be 1. Here,
Yeah.
3 raised to 0 is 1. So any number, these two numbers are equal and they have the same base. So then their exponents have to be the same. Better? Perfect. So let's look at the last one, which is log base 3 of 9 is an unknown number y. I know how to change this into an exponential equation, and that will make my life easier. So, how do I do that? Counterclockwise, and I have to start with the base. Good. I can write both sides with the same base. 3 raised to y is the same with 3 raised to the...
Second.
Good. Two numbers are equal, and they have the same base. What has to happen to the exponents? They must be the same. And this is 9 going back to 2. Therefore, we can conclude that 2 to the x and log base 2 of x are indeed inverses of each other. They are indeed inverses of each other. From this section, I just want to work on writing an exponential as a logarithmic equation and vice versa, and then answering a couple of, or solving a couple of equations. And I'm happy here. So on page 749, I have 8 minutes left. So I have page 749. It says write as an exponential equation. So we are given a log equation. Please choose. And the problems are from 1 through 16. 1 through 16 on page 749. We are given a log equation. We are asked to change it into an exponential equation. Okay, number 8. Log base 8 of y is 7. This is equivalent to eight. So starting from the base, counterclockwise, 8 raised to 7 equals y. Very good. What about 14? Log base 1.2 of 1.44 is 2. They only want us to do nothing else but just replace it by an exponential equation. Raised to the second power equals 1.44. Okay. Would you like to choose another, or look at the other way around? The other way around? Okay. The other way around may look more difficult. So let's try 20. So please keep this in the same order and you will not make a mistake. So here's what I like to do. I am given the exponential equation, so I'm writing it on this side. I forgot, what did we pick? We picked 20, yes. So 10 to the 4th equals 10,000. So on this side, I put the symbol log. I know I have to have a base. I know I have to apply it to a number, and I know I need an answer. But now it becomes easier because I know how to change it from an exponential to from a log to an exponential. What is this? Right. What is this? Exactly. And of course what this should be? Exactly. So if you keep it in this order, you will never make a mistake. It appears that changing the exponential into a log is more difficult, but it's really not if you're just keeping in the same order. So please choose another. For example, 28 looks awful. So I'm writing it on the right-hand side because it's exponential. 4 raised to 1/3 equals the cube root of 4. Don't get scared. Just put the symbols in there. Log, you have to have a base, you have to apply it to a number, and you have to have a final answer. So what is the base? Exactly. What number do I raise it to? 1/3. So this is the base and this is the power, 1/3. And what do I have here? The cube root of 4. Okay, just one and I'll stop from 29 through 44. We know how to do these, but let's work on one problem. 29 through 44. Please choose anyone. Which one? 44. Very good. Looks awful. It's not at all. So log base 3 of 1/9. I have no clue what this is, so I'm going to say it's a number y, but I know the equivalency. This is equivalent to yes? Yes? Good. Now I know that both sides have to be presented with the same base. There's nothing I can do to the left, but there is something nice and easy that I can do to the right. And it has to be with the same base. I shouldn't say it has to be. In this course, it has to be, because we don't know other options yet. 3 to what power is 1/9? Since it's a fraction, the power must be negative. Exactly. So now I have two numbers, they're equal to each other, and they have the same base, and I know the answer. Y equals -2. Yes, these exercises, these problems can get difficult, but not in this class. Okay, thank you very much. If you have any questions, please stay. We made a lot of progress.